It's always the thing, like, we're going like centralizing our law. Look for it at 6 figures. Just like the picture.
Oh, so you're actually using it?
Yeah. Oh, yes.
No, so it was only worth $90. I don't know why Google said no, but it's $90 if you trade in a Pixel 7 for a 9.
Based on my CRT experience, the attackers all.
You trying to get rid of a Pixel 7?
No, that's my. I have two Pixels now because when I went to a trade in, they said that the 7's only worth $90.
Right.
They were like doing deals before where the previous Pixel version was at least $100.
Alright, everybody, we're going to get started. Grab a seat. We usually start late, but we're going to try to start on time from now on. So, thanks for coming. If you haven't been here before, we've been doing this for about 2 years. We are a 501c3 now. We raised about $1,000. The cost to rent this place is like $50 a month, and then we have like gives us about 6 months of money, I guess. So, so we're trying to be ultra low budget. We're trying to have a conference-like speaker, have intellectuals, cybersecurity intellectuals attend our monthly meetups. If you're familiar with DEF CON, it's a DEF CON group. So that our mission, revolves around the meetup, but we have a long-term goal of starting a hackerspace like Section 7 over here. So they were our fiscal sponsors, so you haven't been there, check that place out. Other than that, thanks for coming. Tonight's speaker is Kevin Bong. I saw Kevin speak at DerbyCon in probably 2015. I don't know if it was on the MiniPwner.
I think I borrowed some of these content for these slides.
Yeah. So that was still when I'm a blue team analyst and I was aspiring red teamer at that time. And Kevin's talk super inspired me. Didn't know that he was a Wisconsin local at the time, even though we were in Louisville. So it's great to come kind of full circle and have him speak with us tonight. And I'll turn it over to Kevin.
Cool. Thanks, Ryan. Hi, everybody. Yep. So I work for GoScale now. We're a newish company. Our headquarters in here is Madison, doing pen testing and fun stuff like that. I also do a lot of hardware hacking villages at conferences. So I've done every CypherCon since the first one, as well as like SecretCon and a few others up this way. So what we do at the, I kind of have a passion for conference badges. What we do at the conferences nowadays for the hardware villages is we actually let people sit down and solder together what's my business card into like an active kind of badge. So I've got some business cards on the back table there. If you don't have one of mine yet, grab it on your way out. And then come see us at CypherCon or SecretCon or Grassroots or ThoughtCon and solder it together. But what we're going to talk about today is hardware and badge hacking. Like I said, we're always running the hardware village, and constantly people are coming up like, oh, I want to hack this badge that I just got. It's pretty cool. I see people doing that. How do I do that? And so this is really just about what tools are going to make that easy without spending a lot, because I'm also a very cheap person. Some of the passion behind like my business card, it does some of the same things that like a Flipper Zero does, but it does them for like tens of dollars instead of hundreds of dollars. So that's kind of the goal. And so the goals of, general hardware hacking, talking about I want to break into this router or this phone or something like that, is very similar to badge hacking. We'll talk about some of the differences, but we have a lot of the same goals. Extract data. Can we get to secrets on the device? Can we figure out what it does? All that kind of stuff. Finding hidden features. So especially on the conference badges, especially for like CypherCon, there's layers upon layers of stuff going on there. But what does the badge do? How can I maybe turn on additional behaviors or do more with it that somebody else is doing? More for the hardware hacking, bypass security controls. So I've got this. We do a lot of hardware testing, and it seems like every widget that every company makes, they now make that widget with a Wi-Fi add-on module. And so it's like, how is that Wi-Fi add-on module secured? How are you going to get into that generator or that oven or that whatever sewing machine if this hadn't been built right? And ultimately, maybe even change device behavior. Can we, change the firmware, change some settings, do something interesting with it? So, and really the first tool to start with you already have is your cell phone. You get the device, and I have really bad old eyes now. My glasses are here. And I can't see these boards anymore just with my own eyes. But cell phones work really well. You know, get a good angle on the light. And what you're looking for when you start inspecting a device, a badge, an embedded device like that, is start with what are the chips on it. You know, if I look at this one, the far one on that end, if you can just barely read it, it says ESP32 something. And I know an ESP32 is a microcontroller, a very, you know, specific series of microcontrollers that does like Wi-Fi type stuff and things like that. I also see over here on this one, it says FTDI. If you're not familiar with FTDI, that chip talks between a microcontroller and a USB interface in like serial protocols. So that tells me a lot. Somebody, you know, purposefully put a chip on this board that lets you talk to it like a USB cord or a serial protocol. That's probably something that's going to be really interesting to figure out why is that connection there and what might it talk. So yeah, getting a good zoom in on this. A lot of the other chips, I'm not sure what that center chip is. Its shape tells me it's likely a memory chip of some kind, but it's all mucked up somehow. The one up here on top with the like 5 pins is probably a power regulator. So not all of them are logic or smart things. Some of them are things like power regulators. But yeah, we talked through some of the common components. You got a processor. Nowadays, sometimes the processor has the memory built into it. Sometimes there's memory next to it. You've got, just like a regular computer, you've got two types of memory. You've got the flash memory that would be, you know, this persists across reboots just like a hard drive. You've got RAM. We'll see in a slide here, the RAM is actually in some devices the exact same as the RAM is in your computer. And then, yeah, communication protocol chips. You know, that ESP32 tells me this device might be Wi-Fi. That FTDI chip tells me this device might have a serial port that I can talk to. So kind of looking at all those things and at least understanding what's on this board, what type of chip does it have, gives you a lot of information about the board. And I think I just talked through this one with the ESP32 and the FTDI. Another example here, this badge has Amtel Mega 32U4, which, you know, doesn't tell me much when it's just on the board, but it actually, that's the same chip that's on an Arduino Pro, or Arduino, what is that, a Micro? And the cool thing about that chip is that it does USB in software. So, you know, if you're like, okay, well, I've got this board, I want to do some testing with it or inspection with it, you can just pick up a $4 board with the same chip on it that you can easily program and do some cool stuff with. So those two were Hacker Conference badges, and very typical Hacker Conference badges in that they're using lower end chips that cost, as you saw, maybe $3 for that chip. This is actually a not a Raspberry Pi, an Orange Pi, an older Orange Pi device. So like a router type $40, $50 device or whatever. But it's the same thing. You're going to have the processor. It's an Allwinner H5. Here's that memory chip I was talking about. That's the exact same memory chip that you get like on a DIMM, what is it, DDR3. You know, you see a series of chips on your DDR3 memory module. That's one of those chips. It uses the same memory, soldered right on the board. And we can start looking at some of the other things there. So the RTL 8211, that's an Ethernet controller, and it makes sense. The port right next to that is an Ethernet port. The Realtek there, I think this has a VGA interface, so that could be VGA or something like that. But yeah, you see it's kind of the same basic structure. A big difference though when you go from these conference badges, they're typically running, they're not running an operating system. They're running whatever application they run bare on the chip. So you can't really log into it. You're not going to get a command line. It's a very small, one single thread of a process that it runs. Whereas when you start looking at testing higher end devices like this, whether they're, again, IP-enabled phones or routers or a Raspberry Pi type device or whatever, it's a lot more like a computer. Most of them run Linux or Android or things like that. And you can potentially get an operating system or at least a command prompt where you can do some interesting stuff. And that's just that memory chip. So after you've looked at all these chips and written down the numbers, the next thing you want to kind of get used to is data sheets. So data sheets are whatever the manufacturer of that chip produces, but they're really, really helpful. They'll tell you, things like what is the purpose of every single pin on the device. So if I see that they're using ESP32, and I can even maybe follow some of those traces or see what some of those traces are connected to, I'm going to be interested if there's anything connected to these two pins, because they're the default RX and TX serial port. That's kind of the default debugging port. Or do they have something on one of these other ports, RX or TX? If they've got a memory chip, it's probably an SPI memory chip, in which case it's going to be connected to one of these sets of SPI protocols. So again, the data sheet for the processor will tell you what voltage does it run at, what do the different pins do. Really helpful stuff to kind of, again, even before you've really touched the board with anything, you can learn a lot about it by looking at the traces, looking how it's connected together, what's connected to what, and are there debug ports, again, instead of these pins would tell you kind of what protocol is likely on that port. And from there, yeah, you're inspecting the circuit. So I've got a Novaton chip in the middle there, the big one. This is a really cheap RFID reader. If you look at the other side, there's going to be like a keypad for the RFID. So this is a nice one though, because you can see how easy it would be to, kind of trace, follow the traces and figure out how it's connected together. If we turn this over, I think we'll find on the other side the memory, or the EEPROM chip that stores the memory, that stores, in this case, it would be like the cards themselves, the numbers for each card would be on the other side. We could follow the traces to see where those are. Most devices that you end up working with nowadays aren't going to be this simple though. If we go back to this board, the traces are not just on the front and back, but it's maybe a 4-layer board or something like that, where there's traces sandwiched in the middle that you can't even see. So, and so it's kind of hard to, say like, how is this connected to that? And the other part of it is too, if we go forward, that chip, all the connectors are on the edges of it, and they're pretty big connectors too. So we know where all the connectors go. If we look at a chip like this or like this, they're called a BGA connector, meaning underneath that chip is little balls of solder connecting it to the board that you can't see, that you can't put a test probe on. So another reason that you can't really trace those. But other than the memory chip and the processor chip, most of the other ones do have exposed pins that we might be able to get a probe on and learn something about. So those are the types of devices that we're kind of targeting. And after we've kind of looked at it, got an idea of what we might be looking for, now we get into some of the tools for the toolkit. The first tool is a multimeter. What does a multimeter do? It lets you, between the two little probe ports, I should have pulled mine out. So I've got a bunch of different settings on the front here. I can turn it to DC volts and put this across a 9-volt battery, and it's going to tell me 9 volts. If I put it across on a circuit there, ground and a pin on the processor, it's going to tell me whether that processor is running at 5 volts or 3.3 volts or potentially 1.2 volts or something like that. So voltage can tell you a little bit about a circuit, just about which pin is ground, maybe which pin is 5 volts in. And if I put this, doing voltage, if I put this pin on ground and start touching this to other signals, if there's an active signal that's like sending data, it'll likely show as something less than 3 volts or something less than 5 volts, because it's not going to be transitioning as quickly as that signal is. It's going to average it out and say, okay, well, if there's a signal half the time, it's going to say 1.5 volts. So that can help you kind of pick out at least where maybe there's a signal being sent or being transmitted. So that's helpful. So the voltage on this is helpful. The other setting on this that's helpful is ohms, which tells you resistance. So right now I've got it set to ohms. These aren't touching, so it's telling me there's infinite resistance. There's no connection between them. And when I touch them together, it goes down to 0. Well, almost 0, 0.1, which is helpful to turn off the board that you're testing, put one on a known ground, and then you can find other grounds. Or if you see a data pin on your processor, put one end on that data pin on the processor, and then look for other points on the board or other chips that have zero resistance between that pin on the processor and that location. And it's another way to kind of follow that trace through the board when you can't see it. I've used these cheap kind of AliExpress Harbor Freight tool $7 multimeters forever, and they work just fine. What they don't have, which I would like, is a lot of them have a continuity, like a sound level. So basically, if I'm trying to do that continuity test, hey, does this pin connect to this pin? I'm looking at both, I'm setting it up, and then I look down here and see if it's 0 or not. So I'm trying to look in two places. If it's got the sound, you're just poking around and listening for it to beep every time that there's continuity, that you found two pins or points or whatever that connect together. So you can get by with a really cheap one there. If you can get an inexpensive one that gives that sound, that's going to be better for you. These go, these are the two options right next to each other on Harbor Freight tools, $7 and $80, for a tool that more or less does the same thing. And yeah, I just talked through all this. So this is one of the CypherCon boards from a few years ago, but you can see they've given us this whole big circle of places where I could solder in a pin or solder in a wire or test something. And likely those are all connected to some of those chips there. But here it would be pretty easy to, put one point on what we know it to be, like the shield on the switch here that's metal should be ground. Or we know the power in, like the negative terminal of the battery is ground. So we can go on that and then go and find other grounds and at least figure out how the chips are oriented and stuff like that. So multimeter really helpful for that first step of what might be interesting places to connect to. And again, interesting places to connect to. A lot of times they're going to be things like these. The developer will have left headers in there, because what they do is when the engineer designs this board, they want test points, they want a header to do programming and debugging, but once they've done all that, they don't want to redesign the board and take those things off of them. So they're still there. For something like a conference badge, they're often made a little more interesting, whimsical like this, but you'll still find those test points or ports. Sometimes they'll be labeled. It'll actually say like TX and RX or something like that. A lot of times they won't, because the engineer doesn't expect like end users to be trying to use them. So an important note, whenever we're kind of testing two things, connecting two things together, first thing we need to think about is connecting the grounds together. So if I've got, we'll talk about like a logic analyzer or this serial adapter, and I want to connect it to, in this case, a little router, each one has a ground. And what a digital signal is it's a 1 or a 0. And a 0 means this signal's a ground, and a 1 means it's usually 3.5 or 5 volts, or, actually it's, half that or whatever transition it is. But you can only test those things between two devices if they both agree on what ground is. And they might not agree on what ground is. If one's connected to a battery and one's connected to the wall, suddenly when you connect them together, there could be some charge flowing through the ground. Doesn't hurt anything, but that gets them to both agree on, okay, this is ground, so then every signal that's above that or below that makes sense. So that's just one thing to think about is, when you got multiple devices, you're typically just connecting the grounds together to make sure everybody agrees on what ground is. And then, yeah, after we found those points, you can get somewhat more expensive like kits for test probes that get, kind of stuck into places and held in those places and all that kind of stuff. As long as I've been doing this, I've just been using a soldering iron to kind of solder on a wire or a point or something like that. So my comment used to be the one place I don't recommend going with the cheapest, because if you get a really cheap soldering iron, you get really frustrated. I have a caveat to that, and that caveat is if you go on Amazon or AliExpress and look for the ones that look just like this with a little yellow knob on them, we've been using these for our hardware hacking villages. So it'll sit powered on with new people using it for 3-4 days straight, and they work just fine. So I've been pretty happy with these. So if you're just going to do this once in a while, you're not trying to spend a lot of money, you'll probably be pretty happy with one of those soldering irons. If you're going to do this regularly, you're going to be even happier with the better soldering irons. Better soldering irons just work better. They heat up faster. They'll have a little, actual digital display to show you what the temperature is. The tip is made of a material that just works better, holds the solder better. But again, we're pretty successful with these. And they get some solder. So you can buy safer solder that's got less lead or no lead, and you're going to get really frustrated if you do that. There's a reason that people like leaded solder, because it works so much better. I am going a little bit insane, so maybe that's why, but I still use the leaded solder, and it's probably a lot of reasons. And then another tip, if you're going to be trying to solder wires onto some of these really tiny signal points, I've for years used not really thick wire, but it's for all intents and purposes thick wire compared to the tiny little chips we're working with today. The better way to do that is to get, they call it magnet wire. It's a really thin wire, and instead of like a plastic sheath, it has a lacquer sheath that's almost just like sprayed onto it. And instead of stripping that with a stripper, the trick is to have a little glob of solder on your soldering iron and just dip the wire end into that, and you can see it kind of melted and cleared off the solder. But that only works well if you get not high temp wire. So you got to look for, they actually rate like what temperature is this wire good for the magnet wire. If you get 155 degrees, apparently that works pretty well. The nice thing about that, because if you start soldering on kind of your standard bell wire, or even something like you get some like Cat 6 cable and you pull the inside out of that and start using those wires, they're stiff enough that as you're moving stuff around, they're breaking free. Maybe they're even breaking the pad off the board or something like that. These really thin magnet wires, other than snagging them on something, you don't really run a risk of messing up your board nearly as much, and there's such a tiny wire you can really get them on those tiny little spots as well. Soldering iron. Which gets us to the next and kind of one of the main tools I want to talk about here, which is a logic analyzer. Logic analyzers are really cool because they're really inexpensive. This is $12 on Amazon, which means you can get it for half that on AliExpress, obviously. I've got one that's a little bit bigger here, but the inside of the guts of it are the same as the one there. Yeah, and I'll show you how we use that. So all of these kind of cheap logic analyzers, you go out to Amazon, you're going to see these cheap ones, and then you're going to see $80 and up ones that are like name brand, and C-Logic is one of the main name brands. And you can actually use the C-Logic software with these cheap analyzers, and that's what I'm doing here. So I'm going to switch over to the logic analyzer software. So what does a logic analyzer do? So I plug this end in with USB into my computer, and then it's got, I think it's like 10 wires here. 2 of them are ground, because whatever you're testing you want to connect to its ground, so everybody agrees on what ground is. And then the other 8 wires here are data signals. So you connect them to whatever test points or interesting points you might want to measure. And once I've connected it that way, I can go ahead here and click capture, start capture, and it's looking for signals on those things. And I don't actually have my board powered on, so if I go power on that board, we're going to start to see at the top that, hey, it's getting some signals. We'll stop that capture. So I just randomly plugged 2 of those data wires into 2 pads on here that, looking on the internet, I knew were going to be kind of interesting serial communication signal. But when I've done this before, when I didn't have that information, I might have all 8 pins connected, and I'm doing the same thing, trying to figure out which ones look like interesting signals. So we did that capture. While it was booting up, it sprayed some stuff, to the screen, and what it sprayed is just data signals, which, it's cool from the perspective of it gives you some sense of what does a data signal actually look like. Ground 5 volts, ground 5 volts, ground 5 volts, ground 5 volts, and like the data is how long or how many peaks or whatever that is. But the next step is to try and figure out what is this data signal. Our assumption is it's going to be serial data because of the type of device. But if it's a connection to a memory chip, it might be a SPI data, which is a different protocol, or EEPROM data, which is a different protocol. But here we're going to assume it's serial data. And the logic analyzer has a pretty cool feature called an analyzer. And so I'm going to add a new analyzer, a serial analyzer. Okay, so the interesting data is on channel 0, so we'll set that to channel 0. And the bit rate, if you've done any serial work, you know, or if you like me, were like trying to manage a bank of US robotics modems for the school in 25 years ago, you know, that's like 9600 or 19200 up to kind of 115-200. The common date rates today are like 115-200 at the fast end or 9600 at the slow end. And we can start just kind of guessing that to see if we're guessing correctly. And I'm going to check some of these other settings. I don't think we want inverted. I don't know why that's their default. So if I save that, it's going to try and decode that signal using those settings. And that doesn't look like it's decoding it correctly. That looks a little bit messy. So let's try a couple different settings. We could also like measure the width of these signals and use some math to figure out what the data is. And if we were really getting stuck, that might be an approach we take. But I think for now, we can just trial and error if I can click in the right place, which I did not. All right. Oh, here, okay. So I'm going to edit our analyzer here. We'll try the next most popular one, 9600. Save that. We're still seeing errors. And what we're seeing actually is, you know, that big green bar is supposed to be one letter, but obviously there's a lot of data. So 9600, that's way too slow. It's going to be at least a faster speed than that. We can try other speeds too. 38400 is usually the next most common. For whatever reason, I do know that this vendor uses 57600. So if we set that, suddenly, oh, that looks interesting. I'm actually seeing a word there. What, filtering? So yeah, it looks like we found that this pin is serial data and running at 57600 baud. And we could export this to get whatever the data is or whatever, things like that. So that's kind of the approach we take with the logic analyzer. I should show that though. I think we can, yeah, we can save, we can export raw data, we can save the capture. So another way I've used this is if we connected this to that image of that badge reader, and we're connecting signals off the badge reader, we could be sniffing the signals off the badge reader, like maybe the communication between the memory chip and the processor, because every time someone reads a badge, it probably has to send all the badge numbers, or at least a bunch of the badge numbers, from the memory chip to the processor, so the processor could compare them to the badge that was just read. Especially if it's a badge that's not in memory already, it's going to send them all over. So we could capture that, figure out what the, you know, if it's I2C or whatever, SPI, do the decode, export that to a file, and now I've got a file with basically all the memory, all the contents of that memory chip. But in this case, we're seeing serial data. Interesting way to then go look at that is to connect directly to it with, well, I'm probably getting ahead of my slides here. Oh, I am getting ahead of my slides, so. All right. So I was showing you that commercial software I was just in was the C-Logic software. There's an open source program called PulseView that does a lot of the same things. So if you're really into open source, you've got that option. But, so now we've figured out what those two pins are. Now we actually want to connect to them and talk to them. For that, if it's serial protocols, we'll want a USB to serial adapter. Again, this is $6 on Amazon, which means $3 on AliExpress. If you're willing to wait, it's like, what, 2 weeks nowadays if you get like the choice free shipping or whatever. And it's like Christmas because it all comes like 10 different things in one package. It's bad. I spend so much on AliExpress. But one good thing to look for on this, you can see that yellow jumper. Is anybody here not familiar with jumpers? Because we don't use many of them nowadays. But basically, it's a little plastic and metal thing that you'd pull off a pair of pins and put on a different pair of pins. Since it's over on this side right now, it's set to use 5 volts. So it'll send 5 volt signals, it'll read 5 volt signals. But if you move it over to the second set of pins on the other side, that yellow tab, it will do 3 volt signals. So it's kind of nice to have that hardware switch. Most of these just do 5 volts, which works for 3 volts because 3 volts is close enough to 5 volts. But if you can have it, where you're doing a 5 volt signal or a 3 volt signal, why not do that? So that's a nice thing to look for on those. I've got one of those right here connected to another one of these routers. So I'll show you how that works. All right, so I've got PuTTY, and actually I'm going to close it and we'll restart it. All right, so we're going to talk with PuTTY on serial, and I need to know what COM port I want to use. There's a trick that I wish I had known years ago. There's a command in Windows called mode. You type mode, and it's going to tell you what your COM ports are and kind of what they're set for. And you can see I'm seeing 2 here, and there's some built into the computer, so I can't be sure these are my COM ports. But now if I disconnect that USB to serial adapter and do mode again, COM3 went away. So now I know for sure that it's COM3 that I was connected to. And we'll just make sure it didn't change. It's still COM3. So yeah, COM3 is my serial port right now. And then I've got it connected to those same pins on this board, ground, that receive data pin, and then another pad that is probably a transmit data pin, just because, if you got receive, you got probably transmit as well. So connected it to the board, launch PuTTY, and we know it's COM3, and we know from the logic analyzer that it's 57600. And the other thing I want to do is use a bigger font so everybody can see what's going on. All right. So we should be able to open that. And now that I've got that open and running, I'm going to boot the device. Hey, look, live demo's working. Look at that. I'm going to hit 4 here. Just so I was quick enough. So look at that. It's like a BIOS for your router that lets you skip booting and drop right out into the operating system. And have some basic commands here. So this is called U-boot. U-boot is a very pervasive open source, basically the BIOS for these types of embedded like router, whatever devices. I think U-boot's on Android phones for the most part. But yeah, it lets you do a lot of cool things before the operating system boots. For example, on the bottom there you see TFTP boot. So even if I can't get into, like at this point, get into the operating system or the memory on this device, I could just boot from my own operating system off a TFTP server somewhere on my network. And maybe from that I'd have enough tools in that operating system I just booted from to go and look at this device or pull memory. So yeah, this is what you're hoping for when you kind of boot off of, get a serial command and boot and can get past that login. Now U-boot has a lot of features. If you're on a secure device, U-boot can help you with the disk encryption. It can be configured so you can't bypass it like this. It's going to just boot straight into the operating system and give you a login prompt. And if you don't know the password, you can't get that login prompt. These are little NEX WT3020 routers. I don't know if they even still sell them, but they just run OpenWrt, so I bought a few of them. And they work pretty well for these kind of demos as well. So yeah, that's kind of the goal using a serial adapter. I showed you the mode command. So now I've got that port, that connection. And again, this is on like a router, a higher end device. If you got a lower end device, it's not maybe quite so easy to talk to it. Maybe, especially with the conference badge, they built some type of interface on the serial port that's interesting, or at least some debug interface. If not, if it's a different protocol that you want to talk, it's kind of nice to have a couple other similar microcontrollers in your kit. Some of the most common ones that are also pretty inexpensive, like an Arduino. So that board is an Arduino Nano. It's essentially the same architecture as Arduino Uno, the bigger one that you're familiar with, but only costs like $1.50 off of AliExpress. It's nice because it just works. It's got its own like USB to serial adapter, so you can program it with USB. You don't need a separate programmer. If you do something weird and like melt it, you don't care because it's $1.50. These ESP32s are nice too, especially if you're targeting a device that's an ESP device or doing something with Wi-Fi or something. There's a lot you can do, or Bluetooth. Those have that built in. And probably the Raspberry Pi, like embedded system there, is getting more popular as well. And something you might use those for is if there's a chip on this board that's the memory chip. I can, based on its label, like this one, 23LC1024. I can look up that part number and see that it's a SPI flash chip, and here's what the different pins are for. I could then, if I've got an Arduino, connect the Arduino to those points to that chip and read that chip. One of the challenges with doing that, so here's the chip on the board, it's connected to the processor. So if I just, solder on those little magnet wires onto the ground and the power and to the data signals, and then I put 5 volts on the power, there's a good chance it's not just going to power that chip, it's going to power everything else on that same 5-volt bus, so the processor and things like that. At which point, if I'm trying to read the chip, the processor is going to try and read the chip too, and it's just not going to work. So a lot of times, if you've got a chip on the board and you want to read the data off of it, you might have to get creative. One thing you can do is they call it chip off. You heat up that whole chip, not with a soldering iron, because that's just going to wreck it, but with a heat gun with a very narrow nozzle. They make them especially for this. But you basically heat up that whole thing until the solder melts and just lift it off. And then you could connect to it and read it. Another technique they call lifting a pin. So if I know that this is the power pin, what I can do is just with the soldering iron heat that pin, and with a thin screwdriver, bend it up as I'm heating it. So I break that connection between this pin and the plate that it's connected to. And that way I could put power to that pin, and it's only going to power the chip. It's not going to power the rest of the device. A little bit of a destructive, maybe not as bad as chip off. Pretty easy to fix. You just put more solder back and it's up and running again. But another trick you can do, most of these CPUs have what they call a reset pin, which if basically it's meant to be, if you touch that pin, it's going to reset the processor, reboot it. But if you touch and hold that pin to ground, it puts it in a held reset state, and so that processor is not going to do anything, at which point you can then do what you want to do. So that's another kind of technique there if you're trying to read stuff off of the board. And then how do you actually read stuff? Oh, I'm missing a slide. That's weird. Oh no, I passed it. Because I was getting ahead of myself. How I do that nowadays is, hey ChatGPT, here's the device I have, here's the chip I have, write a program to do this and tell me what pins to hook up to what. It's so nice. It's crazy. This was like a 2-hour project in the past, 'cause wasn't very good at this stuff for the longest time. And now it's like, yeah, just do it for me. So yeah, that's why it's nice to have a kind of a variety of these different microcontrollers, because once you find out, especially with a conference badge, once you find out what it does, it's likely that the engineer probably used an off-the-shelf library off of GitHub to make it do that, and you can use that same library. And if it's communicating via an infrared, and you happen to think to bring an infrared module with you, you can set that up and talk to it. So yeah, it's a lot easier nowadays between ChatGPT and some of that stuff to do some of that kind of testing. Oh, so we looked at U-boot. We talked about the TFTP transfer. The last thing I want to talk about is glitching. This is a little more advanced, but I really think it's pretty cool. And I don't know why I don't have the right slide content there. But what I want to show you for glitching is a video. We'll see how it works. So the background here, this guy, I forget his name, has a TP-Link web camera, IP camera. And when he boots it into U-boot using the serial port, it goes straight to a login prompt. It bypasses all that kind of, hey, exit U-boot to get to serial. And he wants to break into that serial part. So what he's done is he's identified, okay, and he's done some research, and someone probably pointed him in this direction. But he's found that here's the memory chip that holds the operating system, that holds the firmware that U-boot is reading off of during the boot up process.
We have data out. So data out is what it sounds like. The data is going to go out of the flash chip from this pin to the CPU when it wants to read something that's inside of the flash chip. And so that's what we want to go. We want to ground that pin out at a certain time. We want to be able to ground it at a certain time in the boot process and stop stop it from being able to read successfully, and then cause it to do something unexpected, which in this case is drop into that bootloader menu. So that's what we're going to do. Let's go back to our microscope because we got to solder up some wires. So
yeah, I'll kind of skip through some of the kind of soldering steps. But what he's doing here is on that memory chip, he's identified that's the data line. And then the chip 2 away from it is the ground line. So he's putting just 2 wires onto it. And you can see how just using that thicker wire, that wire just looks huge against that chip. And, that's why I like that really thin magnet wire.
All right, that's a big clump of solder, and I will make sure at the end of this that I haven't bridged these connections. Because again, I don't want to glitch it out the whole time. I just want it to glitch when I touch these 2 wires together. So I'm soldering them on. Alright, that is not the world's best soldering joint, but it will probably be okay for the purposes.
I'll skip ahead a bit.
Pin wires off the connecting my.
So he's just reconnecting it back up.
Perform a sanity check that TX and RX are still connected, and that it will boot fine when I.
So what he's got is 2 wires that he can touch together now to ground that pin out.
Just powering on the device.
And right now, he's just testing that he didn't break anything.
We can actually talk about where we're going to glitch, and this is told to me by somebody else. That second time where it prints out audio negotiate, right there. That's when we're going to initiate our glitch, because that's when it says like reading from the flash chip. Because what we don't want to do is we don't want to screw up the loading of the U-boot bootloader, because then all games are off and we're going to get a crash or something like that, right? Okay. So. Looks like we're still good. Something I want to show you that we will definitely run into here. Where is it? Well, I'll show you guys later. But there's definitely some problems with entering text into the console. Specifically, if I try to paste, you'll see sometimes it does like capital letters instead of lowercase letters, and so. That is a problem, but the copy and paste does work. It's just not echoing it back properly, and I don't know why. And I've checked my ground plane a bunch of times.
All right, I should have skipped this, but he'll do the glitch here pretty soon.
Like
it's kind of cool.
Sometimes you get weird results. But now let's try this again. And again, all I'm doing here is I'm preparing these 2 wires that I have here that we showed. We soldered on to pins 2 and 4 of our SPY flash chip. Then I'm going to wait. Okay, that's the first auto negotiate. Don't glitch yet. And then second one. Okay. Now I'm bridging our pins. This is what I want to see. And we've dropped it.
So yeah, I think that's pretty cool to like bypass that control as simply as just making it not be able to see the memory chip at that point in the boot process, and and apparently it fails open. It fails down to this command prompt. And from here now, you could do things like read flash. I think I've got a couple slides that show how that might be done. Within U-boot, we can tell which device, 0, which is the main memory, read all the data from main memory into this temporary memory position, and then use TFTP to send all the data from that temporary memory position, to this firmware.bin file on this other system, and now I've got a copy of the firmware off the device. So that's kind of what I've had to demonstrate. Anybody have questions? All right, thank you. Yeah.
So you've done this hacking before. Can you tell us a war story of a particular success you had?
Oh, interesting. Okay. A pen test device. Let's see. Boy, my mind's going blank. It's not that sexy, the stuff we come across when we do the pen testing, because like I said, everybody's adding a Wi-Fi module to their widget. And then we get it and we're like, okay, well, if I open it up, you've got a serial, like an SD card plugged in there. If I pull out the SD card and put it in my